Ashley Criswell, and this is a short presentation of my Data Science Capstone Project titled Box Office Revenue Prediction. Today I'll be walking you through the working demo, my implementation approach, key features of the app, and highlight one of the more challenging parts I encountered with a resolution via my code. So for the project overview, I decided to create my capstone to predict domestic box office revenue using public data. So this is designed for studio executives, finance analysts, and data teams. Within these three groups, they have various access to different parts of the Streamlit app, which will be explained further. And at the end of the project, it will generate automated reports through a PDF with insights and visualizations for each of these groups to look at. The approach to implementation, first I had to collect my data. I used data from TMDB, the website via an API, IMDb, and the numbers, which gives access to numerical values behind different movie releases and their budgets. The various models used for this Streamlit app were linear regression, random forest, and XGBoost. And I went with the Streamlit app to deploy my application, and it includes role-based access. It generates downloadable role-specific reports. I've implemented 3 user roles with tailored access. So for instance, finance analysts can run predictions, but they do not have access to raw data. Executives can view and download summary reports made by any other teams, but they can't create their own models. And I'll show you a demo using the data science team next. Here's the Streamlit app interface. So they would have their own username and password login. There is multi-factor authentication used through Google Authenticator. So users have to set up an account by scanning a QR code and then entering their MFA code, then allowing them access into the app. Once verified, they're logged in. It identifies what type of dashboard is available based on the user role. So this one will be a data science team dashboard, and it lets them know what they have access to and they're securely logged in, and you can refresh the session. The help and documentation is available on the side for each of the different tabs depending on the role. For data science, because they have access to all roles, all help documentation is available. So the first one is upload data. This is available to data scientists. So they would upload data that includes key information such as movie titles, budget. It gets a rundown of the different columns involved in the CSV file, and it lets it know it's been uploaded successfully. The different tabs are EDA, data cleaning, feature engineering, model training, predictions, and download report. So if we went to EDA, there are some that auto-generate, like the basic statistics and the correlation heat map, but then there are some variation where different types of graphs can be generated based on the user's interest. Then they would have access to different data cleaning options and handle missing values. Some of these are auto-populated, so they don't have to change them, but they are available to change them. So invalid data points would be movies from 2020 because these didn't get a theatrical release due to COVID, so they're invalid in predicting box office revenue. Then again, it tells them if the option is optional, and then it gives them the final process data, which could be downloaded as a CSV. Once that is cleaned, they can go to feature engineering. They can do a data overview and create interaction features. They have to select features for their model. They also have the ability to create a correlation analysis to decide which features they want to include or explore which features to include in their model. So once they experiment with that, they can go to the model training tab there are different models. It auto-populates hyperparameters that are good for the model, but they are also available to choose other models. And they can move these to experiment with different trees and depths to see what works for them if they're experimenting as the data science team. Then it trains below and it will let them know when it's been fully trained, which then they can go to the predictions and performance tab. In the performance tab, it breaks down the mean absolute error, root mean squared error, and the R squared value, gives them actual versus predicted revenue, and a residual plot. And then finally, they can go to the download report, where again, some are pre-clicked, but they can include different things they want, such as statistic reports, model summary, feature selection, performance metrics, and then they can include whatever visualizations they want, such as a heat map. And then a report preview is generated so they have an idea of what is going to be on their report. Then they have the option to name their report based on what they would like. They can generate it and download it as a PDF. And they can also upload it to the Google Drive. This would allow other data scientists to see this report as well as the executives who have access to all reports. And this is saved in a shared Google Drive. Features to include in the application was the Google Drive integration. I wanted to make sure that each role had access to various folders, but that the files would be saved outside of a local drive. The function that is displayed handles the creation of the Google Drive folders based on the user roles. If the folder already exists, it fetches it. If not, creates a new one. And then this logic ensures that reports are neatly organized per role, like executive reports. For my final model, I chose XGBoost, although all three are available on the application for the data scientist to choose from, because it's well known for handling large, high-dimensional data sets and has a strong performance across many machine learning tasks. It does a good job with missing data, which is important when we're working with movie data sets, which don't always have complete data. And then, although ensemble methods like voting and stacking were considered, I did not pursue them because the XGBoost alone provided the performance interpretability needed for my analysis. And then to address overfitting, I used cross-validation to make sure the model would generalize well to new movie data, and I performed hyperparameter tuning on factors like learning rate and tree depth, which data scientists within the application can do as well. Final thoughts is that the application has been deployed successfully and there's a working product. The project has helped me apply my full data science skill set that I've learned in the past 18 months. In the future, I would like to make improvements to improve the reports and the aesthetics of the application, but I am happy with how it turned out. Thank you.